Have you ever built something on your laptop? Maybe a small project, a web app, or even just a script, and everything worked perfectly. And then the moment you tried running it on another machine, it just refused to cooperate. Maybe a library was missing, maybe the system version was different, or maybe the universe just decided it didn't want your app to work that day. Almost every developer has faced that moment. You sit there asking yourself, why does it work only on my machine? And honestly, that one question is the root of huge problem that existed for so many years in the software development. Hi everyone, welcome back to the DevOps Pro channel. This is Ria Soni, and today we begin a brand new journey, our Kubernetes series. Many of you asked me to create a Kubernetes playlist in English, so I'm really happy and excited to finally bring it to you. For all of you who don't know me, I am a certified Kubernetes administrator and certified Kubernetes security specialist. I truly enjoy sharing my knowledge, and I want you to know that you are in good hands. You are at the right place to learn Kubernetes because here at DevOps Pro, we explain every concept in the simplest way possible so anyone can understand it. To get the most out of this video, make sure you watch till the end so you walk away with the real value and much clearer understanding in your hands. So let's get started with today's topic. Before we talk about what Kubernetes actually does, we first need to understand containers. Because learning Kubernetes without knowing containers is like driving a car without knowing what a wheel is. The car may still move, but you won't know how and why. So let's begin with something simple. Yes, Kubernetes is a container orchestration tool. But if containers don't make sense yet, that definition won't mean much. So, for the first part of this video, we are going to understand containers in the most simple and natural way possible. Let me take you back to the old days. Actually, not even that old. Imagine you are a developer. You finish building your application and you are excited. It works beautifully on your laptop. You are so proud. Everything is running perfectly. Then comes the big moment, handing it over to the operation team for deployment. You zip your code, you write a long setup document, and you say to the ops team, install this version of Python, use this database, set this variable, download this library, and blah blah blah. And please follow all these steps carefully. The ops team tries, they really try, but something always breaks. Maybe their system has a different version, maybe the database is slightly different, or maybe a library just refuses to install, and suddenly your app that worked so well on your laptop becomes a headache for everyone else. Developers blame ops, ops blames developers. Meetings happens, emails fly, screenshots are shared and time just slips away. All because the two machines were not exactly the same. The truth is, before containerization, applications behaved differently in different environments. Your laptop, the testing server, the staging server, the production server, each one had its own personality. And that personality could completely change how your application behaved. This meant setup took time, deployments were stressful, and debugging became a journey no one wanted to go on. Then came containers, and suddenly everything changed. The idea of the containers is actually very simple. A container packs your application with everything it needs: libraries, configuration, dependencies, runtimes, all inside one neat, reliable box. It's like packing your lunch in the lunchbox. No matter where you take it, to school, to the office, or to the road trip, the food inside stays the same. A container does exactly that for your app. You put your app in, along with everything it needs to survive, and it behaves the same no matter where you run it. This completely changed how developers and ops teams worked. Instead of sending long setup instructions, developers created something called a Docker file. From that, they built a Docker image, basically a ready to run package of the app. The ops team didn't need to install anything manually. They just ran the image using Docker. and the app came up exactly the same every single time. No arguments, no environmental issues, no guessing games. Now, I'm not going to deep dive into Docker in this series because Kubernetes is itself a huge topic. We will make a separate course just for the Docker later. For now, all you need to remember is this: containers made it possible to run application consistently everywhere. But here's the thing: the story doesn't end with containers. In fact, this is exactly where things start to get interesting. Containers solved one big problem, yes, but they also opened the door to a brand new challenge. You see, running one container is easy, anyone can do that. Running two is still manageable. But real world applications are rarely just one small piece. They grow, they evolve, they break into multiple parts: front ends, back ends, databases, caching system, messages queues, and each part can run in its own container. So imagine this journey for a moment. You start with just one container. Life is simple, everything works fine. Then your user traffic slowly begins to grow. So you add one more container to handle the extra load. A little later, even more people start using your app. And now two containers are not enough anymore. Suddenly you need 10 containers running at the same time. A few weeks go by, your application becomes even more popular, and now 20 containers are running across a couple of servers. And then one day your app really takes off and you are running hundreds of containers across multiple machines. It look impressive, but now things get complicated. All these containers need to communicate properly with each other. They need to stay healthy on their own. If one container crashes, it should restart automatically. If traffic increases, more containers should come up instantly. And when traffic slows down, the extra containers should go away to save resources. And it's usually around this point that someone looks at me and says, "Okay, Ria, we understand that containers are great, but this is getting out of hand. Do we really have to manage all of this by ourselves?" And honestly, this is completely valid question because the truth is no human can handle this kind of a scale. You can't sit in the front of a screen all day checking which container crashed. You can't keep manually launching new containers every time traffic goes up. You can't personally make sure every server is balanced and healthy. It's just not possible. And this is exactly where orchestration steps in, the hero we didn't even realize we needed. Orchestration simply means having a system that takes care of all these container chaos for you. A system that can increase the number of containers when traffic goes up, reduce them when things are slow, restart them automatically if they fail, spread them across different servers, and keep an eye on everything so you don't have to. The easiest way to imagine orchestration is to think about a music orchestra. You have the drums, flutes, violins, guitars all playing together. If every musician played whatever they wanted, it would just be a noise. But when a conductor stands in front and guides them, everything sounds beautiful. In the same way, we need a conductor for our containers. Without orchestration, your containers will run, but nothing will be in order. Before Kubernetes arrived, the industry already had a few orchestration tools. Docker had Docker Swarm, simple and easy to start with, but it struggled when system became larger and complex. Then there was Apache Mesos, very powerful but complicated and not beginner friendly. Some companies even built their own internal tools, but each of these solutions had some limitation. Some were too basic, some were too advanced, some were too rigid, and none of them fully solved the problem of managing containers at massive scale. Then Kubernetes entered the scene, and honestly, it changed everything. Kubernetes didn't just manage containers, it managed them smartly. It knew when a container failed and restarted it automatically. No manual work needed. It could look at all your servers and distribute containers evenly so no machine was overloaded. It instantly created more containers when traffic increased and removed the extra ones when things slowed down. It could update your application without stopping it, something that used to be very difficult before. And the best part is you can describe your entire setup in simple YML files, like giving clear instruction to a very intelligent assistant. And here's something even more interesting. Kubernetes was created by Google. Google had been running containers at a massive scale for years, long before the world even talked about containers. They took the ideas from their internal systems, improved them, and released Kubernetes as an open source project. Because of this strong foundation, companies trusted Kubernetes instantly. And once cloud providers like AWS, Azure, and Google Cloud built their own Kubernetes services, adoption shot up even faster. Thousands of engineers from across the world started contributing to it, improving it, fixing bugs, and adding new features. Very quickly, Kubernetes became stronger and so popular, more stable, and more flexible than any other orchestration tool available. It solves real world problems: scaling, healing, resource management, automation, all in one place. It's reliable, it's proven, it's trusted by biggest companies. And most importantly, it gives developers and operation teams peace of mind, which is very, very needed, right? So now, when someone asked, "What is Kubernetes?" you can confidently say Kubernetes is the brain, the manager, the conductor, the powerhouse that keeps your containerized applications running smoothly no matter how big they become. Now that you understand the real reason behind Kubernetes and the role it plays, you are ready to move ahead with this journey. This is just the foundation, and there is so much more to explore and learn. But with this understanding, the next concepts will feel much easier and clear. And that brings us to the end of this first video in our Kubernetes series. I hope this helped you understand not just what Kubernetes is, but why it exists and why the whole industry depends on it today. My purpose in creating these videos is simple: to share my knowledge and add real value to your learning journey. And you can also support this purpose. If this video helped you even a little, please share it with at least 3 people who want to learn and grow in the tech. Your one small action can truly help someone start their journey. And of course, if you enjoy the video, make sure you like it and subscribe to the channel. It motivates me to keep making more helpful content for you. I will see you in the next video. Until then, keep learning and keep growing. Thank you.